Panelists, please mute your mic. Vijay ji, Darikan ji. Yeah, namaskar. Good evening to everybody. Our director, Professor S.C. Sharma ji, my colleague, Dr. Leena Gahane madam, Dr. Darikan Kamble sir, and dear participants, we wholeheartedly welcome to this series of webinar on best practices adopted by A++HEIs. In this series, this is the 8th such webinar where we have invited the stakeholders of Vishwakarma Institute of Technology, Pune, Maharashtra. They will be speaking on the theme interactive and experiential learning approach for cultivating innovation among students. Friends, best practices of the institution should be innovative, radical, and out-of-box thinking. It is very well stated in upgrading the quality in higher education institutions that the quality assurance, quality sustenance, and quality enhancement should be the mantra of every HEIs. All these three components are directly or indirectly related with the best practices adopted by HEIs. Now, to achieve this best practice in higher education institution or any sort of institution, we should go with an attitude of SMART. In capital letter, it is S-M-A-R-T. That means S stands for specific, M stands for measurable, A stands for achievable, R for relevant, and T stands for time-bound plans for the execution of such best practices. Now, again, these best practices are related with three basic queries, which every HEI, every institution does have when they proceed with the best practices which they want to. And that is that what they should do, how they should do, and why they should do. Means what, why, and how comes into the picture. Now, instead of self-sufficient, the concept should be self-reliant. That is very well related with our slogan adopted by our present government also. The concept of coming out with this series of best practices to provide an opportunity to the stakeholders of the higher education all over the country so that they can get benefit by the best practices adopted by the other HEIs who are secured A++. There are only a handful of HEIs in our country who are secured A++. So we thought about why don't they share their best practices, their experiences to the other stakeholders of higher education all over the country so that they can adopt few of them. Of course, many of the things they might be also doing it, but at least to some extent they can adopt whatsoever the new thing they find. So with that motto, we have requested the institute from Pune, that is Vishwakarma Institute of Technology, to deliver their address, to deliver their or share their best practices adopted by them. To continue with the same, now I request my colleague Dr. Leena Gahane to please introduce the speakers and invite them for the session. Dr. Leena Gahane, please.
Thank you, Devendra Kaude sir. I hope I am audible.
Yes,
okay.
Please.
Namaskars to all. I, Dr. Leena Gahane, Deputy Advisor NAAC and coordinator of today's webinar, welcome you all, the panelists and the participants and the experienced faculties from academia and industry to 18th webinar in the series organized by NAAC on best practices adopted by NAAC accredited A++ institutions. The intention of these webinars is to bring to the notice of HEIs across the country the efforts taken up by A++ institutions and to create a possibility of direct interaction with the faculties from such institutions. In true sense, it is a knowledge feast to listen to such practices adopted by the institutions for quality culture at their level. Today's webinar is on interactive and experiential learning approach for cultivating innovation among students by Bansilal Ramnath Agrawal Charitable Trust, Vishwakarma Institute of Technology, Pune, Maharashtra. Let me introduce today's panelists on board who will be sharing about the aim, objective, policy framed and implementation for the good change in their institution. The first panelist on board is Professor Dr. Rajesh Jalnekar, the Director of Vishwakarma Institute of Technology, Pune, and leads the team in academics, research, innovation, finance, administration, and HR. He plays the key role in designing policies, oversee its execution, promotion, research and innovation amongst the student and faculties, allocate budget, carry out audits, faculty appraisals, promote student activities, ensure quality practices, collaborate with industries, universities and research organizations, and also work for faculty capacity building and capacity development. His areas of interest include machine learning, power electronics, signal processing, and image processing. He has got a very wide experience of 30 years of industry, research, and academia. He has published over 105 research papers in international journals and conferences, and has guided over 200 UG and PG theses. He has guided 5 PhD scholars and 8 are in pipeline. He has authored 5 engineering books on power electronics. He is also a recipient of many awards, few to quote is Rashtriya Shikshan Ratna Award, National Builder Award, Excellent Innovative Director Award, Distinguished Director Award, and many more. The laureate on board, along with his research and academia experience, has also got a very strong spiritual dimension in his personality. He has successfully coordinated ISKCON's Pune most ambitious rupees 100 crore NVCC project from 2006 to 2008. Like a missionary, he has traveled over 35 countries for academic and spiritual purpose. We are really honored to have you on board today. Welcome you, sir. Second panelist is Dr. Vijay Gaikwad. He is Acharya, that is PhD in Electronics Engineering, and is working as a Dean Quality Assurance in VIT Pune. His research and teaching interests are in the areas of machine learning, data science, artificial intelligence, computer vision, and signal processing. His research articles are published in more than 40 international journals and conferences. Dr. Vijay Gaikwad is reviewer of various international journals like IEEE Transaction on Intelligent Transportation System, Elsevier Journal on Computers, and Industrial Engineering. He has received more than 15 awards, including Dr. APJ Kalam National Award and VIT Shri Award. Welcome you, sir. Third on the panel is Dr. Ganesh Dongre. He is recipient of PhD from IIT Mumbai in mechanical engineering, and he is currently working as a Dean Research and Innovation in VIT. He is professor in industrial and production engineering with a wide range of experience in teaching and industry. Dr. Dongre has more than 25 papers in high citation and impact factor journals and has got more than 20 papers presented in national and international conferences to his credit. He is recipient of VIT Bhushan Award and VIT Shri Award. Presently, he is sanctioned with 3 research project grants from ISRO worth more than 90 lakhs in the field of micro machining and machining of difficult to cut materials. I welcome you, sir. Next is Professor Ashutosh Marathe. He is doctorate and Dean Academics at VIT and has got a rich experience of 25 years in teaching. His areas of interest are data science, pattern recognition, digital signal processing, quality practices, accreditation, academic autonomy, feedback analysis, digital content development, and many more. I welcome you, sir. Next is Professor Rahul Vaikar. He is recipient of PhD degree in mechanical engineering from University of Alabama. He is professor and dean of administration at VIT Pune. He has worked on a prestigious ISRO-sponsored project entitled as Fabrication of Carbon Fiber Reinforced AL-7075 in a roll sheet from worth of 20 lakhs funded by ISRO and UOP. To his credit, he has published more than 15 papers in reputed journals and international conferences. He is enriched with wide experience in academic and research. We also have with us Dr. Vijay Mane, Dean Analytics, VIT Pune. This is all about all the honorable panelists of today's webinar. Now, Professor Rajesh Jalnekar to start with his presentation. Dhanyavad. Over to Rajesh, sir.
Yes, a very good afternoon to all of you. Am I audible?
Yeah, please.
Yeah. It's a pleasure to all of us to be on this panel today to present our best practices. And I'm really grateful to NAAC authorities for giving us the opportunity to present our best practices. So I am Dr. Rajesh Jalnikar, the director of Vishwakarma Institute of Technology, and I'm going to present to you the best practices at our end, interactive and experiential learning for cultivating innovation among students. So I'm going to present to you the detailed philosophy and the way we have approached this innovative practice at VIT. So what is the underlying principle? So our inspiration, we always draw inspiration from the NAAC, their guidelines they give, NBA, NIRF, ARIA, and ABET also. We have studied them in details. And I have tried to align our culture at VIT with the guidelines given by these bodies. And our guidance also, we get regularly inputs and guidance from our governing body, academic board, board of studies, exam boards. We have a research board and admin board also. An admin board, there are various administrators, and research board, there are directors of various research institutes like R&D engineers and others. And also we have various forums where there is an industry forum. More than 300 industries are on our board. Then alumni, 5,000 plus alumni are connected, and 50 plus alumni are very active in guiding us and giving inputs on this. Then we have a faculty forum, 400 plus faculties are there. Around 20 faculty are the leaders at the local level. And student forum also, toppers of our institute always participate and give inputs to us. And also some of the parents, they occupy very high positions and they are really into academics, and they also give inputs to us on various forums. So the vision, I have put it in bullet points, is to make industry ready and future ready engineers. What do you mean by industry ready? The student pass out, he joins the industry, and from day one is ready for billing. But what is the meaning of future ready engineers? We believe that our students would not only join and be ready, industry ready, but also contribute to the development of the industry from the day one itself by their bringing in some character in their work. Then imparting education beyond time and space. These days, when we are learning courses and acquiring a degree, the moment the student gets admission in first year, and by the time he pass out after 4 years, the courses, the technology becomes outdated. So can we impart some education which is beyond time and space? Can he develop certain skills which are valued throughout his life? Can he bring in some culture of learning within himself? That is our vision point. And then our honorable chairman, Shri Rajkumar Ji Agarwal, always wanted that our engineers who pass out should be job creators rather than just job seekers. So in line with this, our mission is, as I told, learning beyond time and space. So we have created a curriculum, the pedagogy, the assessment, which enables our student to learn beyond time and space. Then emphasis is on self-learning, because there is a formal education which lasts for 4 years or 6 years or sometimes 8 years also, 8-9 years. But later on, every person who joins a professional world, in a corporate world, the competition is very stiff. So therefore, he must inculcate within himself the self-learning abilities. And therefore, the emphasis is also on self-learning. Then skill-based assessment, we have studied various job profiles in the industry, that IT industry, the non-IT industry. In the IT industry, there are different profiles like a developer or a non-developer. In a non-developer, there may be a business analyst, a quality assurance engineer, a product manager like this. What are the skill sets required to be successful as a professional in these domains? Even in non-IT domain, there can be a research engineer, an innovation engineer, or a product manager, or a production manager. So what are the skill sets required? We have listed 25 plus skills, and we have tried to map these skills to these job profiles. And then we also try to analyze the students' work and find out what are their strengths. And based on their strength and the skill set required for a particular job profile, we try to map them and develop the students in the 4 years. Then multidisciplinary approach, because the branches are merging, the boundaries are becoming thinner and thinner. And these days, a multidisciplinary engineer will have a different character when he is in the professional world. So our emphasis is also on that. So, and as I told that all the courses at VIT, right from the first year to final year, are directly related to the employability skills. Meaning that, for example, we have in the first year itself a course on robotics, where our student design a robot which is functional. in a group of 4 to 5 students. Also, we have a course on data science, which is common to all the branches, whether it's a chemical engineering student or whether he is a computer engineering student. So because there is a lot of job potential now for data scientists or data science area. So our courses are directly, and we also offer a course on logical reasoning and quantitative aptitude, because that is what matters when you are also seeking a better job in the industry. We also offer courses which are related to humanities, social sciences, philosophy also, which helps a student to manage his stress level and other things. And interactive and experiential learning is what is the emphasis at VIT. So it is totally, I will explain later, it's totally project-based learning, project-centric learning, and an internship-based approach. So that also I will tell. Then focus on innovation and creativity, because it is one of the very important aspect for an engineer to be successful in this world, again, to be very innovative and creative. So I will come to this also later. Personalized career counseling, because students they come from varied background. Some have some personal problems, some financial, some family problems, and if they are not mentally I want to say uh, strong enough to face the challenges in the professional world, in the academic world, then they may not be able to give their best performance. So it is also the duty of the college to counsel the students in their personal domain. So we say that our teachers have 4 roles: teacher who teaches the courses, the research ability in the students. Secondly, a mentor, teacher as a mentor who guides the student in research and mentor and innovation and academics. Third is career counselor, teacher as a career counselor. And fourth is personal guardian. So where I covered this personal counseling. Then education at VIT is centered around these 2 skills sets: primary skills and the secondary skills. So why? Because when we develop so many best practices at VIT, one of them we are presenting today, the experiential learning for innovative abilities, is the foundation of that is the primary and the secondary skills, which we have learned from various literature. We have surveyed various academicians, we have met various industry professionals also, and from them, out of the churning, we have drawn, out of deliberations, we have drawn that there are certain primary and secondary skills. So what are the primary skills? First is the complex problem solving ability. So life is full of complexities, whether it is personal life or the professional life, and one must learn the art of addressing these problems at ease. And therefore, taking the example of engineering, we teach them courses like mathematics, a very emphasis on mathematics, so that they learn the art. Then is the critical thinking. It's very important to think critically at moments, and that is also required in the professional world. So we designed our curriculum, pedagogy and assessment, where critical thinking of the student is enriched. Then next is team building and people management. It's a very important factor. When I as a person join the industry or any corporate or any organization, I need a team. I alone cannot do anything, and therefore I must understand the importance of my team members, to motivate them, to involve them, and to be friendly with them to get maximum benefit. So that is also a skill which we enhance at VIT, and that is also the skill which is enhanced by the practice I am going to present. Cognitive flexibility, how the students or a professional is able to switch tasks from one type of job to the other type of job. Otherwise, it becomes difficult that you say no, ye abhi bahut ho gaya. I will no, let me give some a break to myself. So it's important that I can switch over tasks very quickly. Then judgment and decision making. Sometimes at the top levels, at vice president level, chief executive officer level, it is important that we take quick decisions and we judge the situation and act accordingly. So we at VIT believe that student not only takes a job which is at the say a 5 lakhs, 10 lakhs job and join as an engineer, but in next 5 to 10 years he should occupy the top positions in the society, and therefore enough things have been done to ensure his judgment and decision making capacity. Then service orientation. This age is of service attitude. So whenever I design, so for example, an Apple has designed a mobile where it has so many facilities and functionalities, which is where the user is at ease. When we go to board a flight, there is an air hostess, the crew there who welcomes you with a smile and makes you comfortable. So this is the service attitude. Of course, this example I gave in a general social life, but in professional world also there should be a service attitude amongst the professionals. So that also is being cultivated. emotional intelligence and empathy. It is very, very important. Most of the success of any professional not only depends on his IQ, but also on his EQ. In fact, a major portion of his success, which is decided by his intellect, emotional intellect and the empathy. When I heard this some 5-6 years back, what empathy has to do in the professional world, I was wonderstruck that empathy is a very important character of a person. So, but it is equally important in the professional world also that a team leader or a team member has empathy towards his fellow members or the fellow team partners, so that he gets maximum out of it. And we have a special general proficiency course in VIT which improves the empathy factor amongst the student. And negotiation is to settle disputes, because there are some difference of opinion when you are working in a team. It may be on different levels, but sometimes it is on the professional level itself, how to approach a problem. So it is important that as a professional I learn this art of negotiating or settling the dispute. The character and attitude is very important. Attitude is the one which also takes you ahead in your professional world. And character is what differentiates you from the other. If you have a different character than others, then only I would be successful. And therefore, character and attitude is a very important factor. And this is the creativity and innovation. Even though we list it at the top skill at VIT, I have listed it at the end just to emphasize that creativity and innovation. Some 6-7 years back, when I met Dr. Vijay Bhatkar, who is a Padma Bhushan awardee, and he is the man who designed the Param computer, supercomputer. So I met him and I was talking to him about innovation, and then we discussed that whether we can inculcate the science of innovation among the students. And with that impetus in mind, that thing in mind, we started some innovation at VIT, and we are a major success now. So we differentiate what is research and innovation. Research is something where we need to give a lot of funds, a lot of energy, and a lot of time, and out of that we generate some knowledge. So knowledge creation is the fundamental job of any university or a research institute, and therefore research demands a lot of attention, time, energy, and money, and it creates the knowledge. But what is innovation? That knowledge should be applied for the benefit of the society, and some revenue generation should be done from that. So innovation is where knowledge is the input and money is the output. So unless that knowledge is put into practice for the socio-economic development of the society, that research will not be fetching much of the benefits. And therefore at VIT, we not only emphasize on research, definitely for knowledge creation, but also on generation of money through innovation. So money may sound a little commercial, but money, I mean to say, it emphasizes the fact, it clarifies what we mean. So secondary skills, again, we are our assessment and our teaching learning is focused on to develop this secondary skill. What is the difference between primary skill and secondary skill? It is very different. It is difficult to differentiate, but I will try to summarize it. A secondary skill is which is immediately manifested when he is doing some task, and primary skill may not be manifested immediately, but later on after many tasks are carried out after some years of experience. So memory, the rote learning or memorization is also definitely a skill required, and it's a lower level skill. Another skill is to understand the thing in the right perspective, what is being told in a particular theorem or a particular scientific fact. So understanding is also equally important. Then putting that understanding in your own words and explaining to the person across you is also an important skill. Then presenting to an audience in your own words in such a way that the message is carried out to the audience. The presentation is also important. Discuss means to discuss things with your fellow members, understand their opinions about it, understand your opinion, convey your message, your opinion about the matter at hand, and understand their opinion also, and if required, change your viewpoint about a particular point. Then self-knowledge is to understand where I am standing in a particular domain, whether I am, so that is called as introspection in one level. So these are the 6 lower level skills. The 6 middle level skills are reasoning, ability to reason out certain things, how I am going to reason it. Then analyze things. Analysis we know because engineering is full of analysis. So analyze the things mean to breaking down the things into smaller parts and working out the details. Synthesize means connecting different blocks or different things which we have understood to form a homogeneous thing. Then evaluate means to compare it to evaluation of two different proposals or two different projects at hand. And interpret is to correctly understand the data which is presented to you and perspective. Put it in your own words to give a meaning to that interpretation in your own words, to your own opinion about it. That is the perspective. So this is also taken care of at VIT. Every student is going to this 18 secondary skill and 10 primary skills. Now I will talk about the higher skills, programming. So the higher skills are programming. These days programming is a very important skill. And most of the recruiters, when they recruit the students, they recruit based on how is my programming ability. And most of the jobs, whether he is from mechanical engineering or from chemical engineering or for that matter electronics and computer engineering, the hiring is totally decided by the programming ability. And therefore at VIT, even a mechanical engineer student or a chemical engineering student is given an opportunity to enhance his programming skill and learn certain computer related courses like machine learning, artificial intelligence, data science, and so on. Hands-on, students do a lot of hands-on things at VIT, which I will explain later on. Then apply. So whatever knowledge I learn, I must be able to apply it and put it into practice. Then designing skill, and then knowledge creation skill is important. And lastly, which we taught in the we discussed in the primary skill also, is the empathy. Now, what is so based on this primary skill, secondary skill, our mission and our vision, what we have done when we discussed in various forums, various inputs from NAAC, NBA, and other bodies, discussion with our governing body, academic board, board of studies, our exam board, our research board, our admin board, and various forums of our students, parents, alumni, industry, faculty. What we churned out? We churned out that normally in an engineering one semester, there are 5 courses, 5 subjects which students need to learn. And those 5 courses are generally theory based, where a theory is taught in the classroom and some laboratory sessions are carried out in the lab. So what we have done is change the way we look at them. So out of the 5 courses, 3 courses are project based learning and 2 courses are project centric learning. What is the meaning of project based learning? Project based learning means we teach them some theory and we learn that theory by doing it through a project. So therefore at VIT, every course, whether it is a physics course or a chemistry course or a data science course or a computer programming course, or for that matter, electronics engineering course or a civil engineering course or a mechatronics course or a applied mechanics course, there is a project for that course apart from the lab experiments. So we call it project based learning. And the other concept is project centric learning. In the project centric learning, we don't teach them any subject. We give them a case study. We tell them that this is the problem that exists and you need to approach it now. You need to address it. We do not know whether the problem can be addressed by using mechanical engineering knowledge or computer engineering knowledge or electronics engineering knowledge. The student need to understand the problem, the situation at hand, the case study at hand. Details of the case study is to be done. The domain specific knowledge is to be gained. Then he need to learn the tools and technology to address that problem. More about this will be followed in this presentation. And this is what is the theme of our innovative practices, our best practice. So what is the objective of this project-based learning and project-centric learning? So little overlap is there. Generally, it is thought that the research work or the innovation is to be carried out only by the doctorate students or master students. But it is hardly thought that research ability or the innovative ability can be inculcated amongst the young minds even at the first year level of engineering. And therefore, we want research throughput or innovative throughput from our UG student right in the first year. So this is the main theme of our best practice. How that can be done? Then they should develop an attitude. See, once when we pass out, most of the time as an individual, I am self-centered. I am happy with the job which I get, the money I get, and the happy family I have. But whether I am looking at the society to address the socio-economic problems. So that attitude of looking for problems in the life of people and to address them in the various domains is the attitude is inculcated. Next is project-centric learning. So we want students to give the project-centric learning approach, which I just explained, through a case study-based approach. Then inculcate research and innovation culture. It's again the same, that research and innovation, that culture should be inculcated among the student. Learn latest tools and technology on your own under the guidance of a faculty. So as I told that earlier, that we cannot always teach them in the classroom. Some time has to come in their life when they have to learn on their own. And they need to understand that this problem, I have to learn so many tools and technologies, and then I must learn it on my own. There is a university in Germany where there are no theory courses taught in the class. There are only 5 projects given to the students. The 5 projects may need knowledge of, one project may need knowledge of one theory subject, or it may need knowledge of more than one theory subject. And the student need to learn the theory under the mentorship of a faculty and then solve the problem. The same model is being implemented here in the project-centric approach. The problem statement is given and the student need to learn tools and technologies to address it. What are the tools? What are the technologies? What are the domains? What would be a typical case study? I am going to take it now. The enhance the self-study culture, which I have highlighted. So there are plenty of MOOCs developed by our own faculty. Not only the plenty of MOOCs are available on other platforms like even VIT has an EduPlus Now platform where a lot of MOOCs are available. But our faculty have developed more than 2,000 MOOCs. And then they should study the research paper also. They should study the literatures also, various literatures and books. And then we have also set up a MOOC studio also at VIT, where our faculty can develop their own MOOCs. Improve industry connect. Generally, the projects are done at the final year, in the final 7th and the 8th semester, and some of the time the projects are sponsored by the industry. As I told in VIT, the projects start right from the first year, first semester. And this helps the student to approach the industry, get the problem statements, and improve the industry connect also. And then the student may join the internship at the end of the first year, second year, third year in the summer, or it is mandatory to do them internship at the 7th and the 8th semester. So in VIT, internship for 6 months, that is 1 semester, is mandatory. And I'm happy to share with you that last 4 years, from 2016 onwards, 100% of our students, which are around 900 students every year, they do industry internship. And most of the internships they get converted into job offers. And the internships are offered by NVIDIA, John Deere, Emerson, and other companies. Develop entrepreneurs. This is in line with our vision of our honorable chairman, that we should not be, our engineers should not be only job seekers, but they should be job creators. And they should give sufficient guidance, and every project-centric approach give them opportunity to develop products, file patents, and have their own startups, and write papers also, publications also. Team building and leadership, through the project-centric approach, they work in a team and they learn the art of team building and leadership also. Promote experiential learning. Now I will talk about the contextual features. So if you see from the first year to final year, and if you divide what the student learn and how the student learn. So there is hardly a theory in the classroom which is chalk and talk type. 35% of our courses, of the total credits they earn, out of the 160 credit is the guideline given by AICTE. So out of the 160 credit, 35% of the credit they earn through project-centric learning, which I have just narrated. 35% is earned through project-based learning. They learn a theory and then they implement that theory in a laboratory through a project, learning by doing. 10% through internships, and 20% the theory which is being taught in the class is not talk and talk, it is MOOCs-based flipped classroom. What is flipped classroom? Flipped classroom is normally in a classroom, a teacher teaches some theory and the student learns on his own, does the assignment on his own at home. But the concept is flipped. The student learns the theory at home through the MOOCs developed by the faculty, and in the classroom or the laboratory, the student discusses the queries he has, does the project he has under the guidance of the faculty. So the concept is flipped, therefore it is called as flipped classroom. And flipped classroom is being implemented in VIT again from 2016. and very successfully implemented, one of the successful model in the country. So coming back to the interactive and experiential learning for creating innovation, which is project-centric learning, there are 2 courses every semester which we offer out of the 5. 3 are project-based and 2 are project-centric. So what we do is, each course is of 4 credit. It's a full credit course. And there are 2 courses, engineering design and innovation and software development and innovation. So in both the courses, innovation is emphasized. And it is an innovative project, and very important that no project or no case study is repeated. If you see in the last 5 years, what case studies have been carried out or what project-centric projects have been carried out by the students, they are not repeated at all. And every course, as I mentioned, is based on a case study. So a typical case study or a typical experiential interactive learning happens like this. There is a case study. It belongs to a particular domain. Some technology is to be learned to address that case study, to address that problem. Some tools are to be learned to implement that. And therefore, the student develop an EDI project, engineering design and innovation, or SDI project, software development and innovation. Now, when he starts this project-centric learning, what is his most important job? Is to identify a domain and learn the domain. So I have listed here some of the domain: agriculture. So the socio-economic angle is to be given to the student right at the first year itself. So there are so many issues at in agricultural domain, because India is predominantly an agricultural country, the farmers' country, and therefore so many problems are existing. I will request Professor Dongre, who is research and innovation, to add about one of the project we do under this agriculture.
Thank you, Director Sir. So one of the project that we are doing under the agriculture is the fruit plucking system. So basically we want to pluck the fruits from the tree by using the robots. So we want to use the robotics and automation in agriculture. One typical problem that company, United Phosphorus Limited, Mumbai, a giant in a fertilizer supplier. So that company given a project that can you pluck a tea leaves? Now the question will come into the mind that why tea leaves? So tea leaves are very, that project plucking of the tea leaves is very interesting project, because the tea leaves, the aroma of the tea leaves is attracted by the snakes, and snakes are getting attracted to that aroma, and they will go there at the tea leaves and they will live there. And when the plucking of the tea leaves is happening, the ladies, generally the ladies are plucking those tea leaves very with a very fast rate. So there are snake bitings are happening, and there is a lot of mortalities are happening or deaths are happening due to that. So to minimize that, can we make that automation in that tea leaves plucking? And we have taken that project. Now that project is very complex one. So why the project is complex? The first thing is that there is an introduction of the automation, so robotics is there, and also the machine vision system is required, because we have to plug the tea leaves which are of particular age, means of the days, and we have to plug those tea leaves, and we have to do it very fast with a faster rate than the human being. So that type of project is given or sponsored by the industries, and our students are doing that type of project in agriculture domain. I have some 2-3 more projects to explain you. I will explain it in the time of a case study.
So here the student need to understand the agriculture domain. What are the intricacies in that? What are the problems in that? So he must study, and substantial time is spent in studying the agriculture domain. The other domain, I won't explain now details of this. Healthcare. What are the issues in the healthcare? Can I pick up a healthcare issue? So that is healthcare. Another is defense. Can I contribute in defense? And I will tell you, in each domain, hundreds of projects are being carried out. To give just a number, around 9,000 projects are done every year in VIT. Every year, I am saying. Smart City contribution, VIT students have been shortlisted by Pune Municipal Corporation also for Smart City projects. Automobile industry also. Then energy management, that is one of the key domain. So the students do project in this domain also. Green Earth, home security system, waste management, clean water, food technology, smart vehicles, intelligent transportation, renewable energy, one of the key domain, and security and surveillance, rural development. So such 16 domains are identified which are unique in nature. And as I mentioned earlier, substantial time is spent by the student in gaining the domain knowledge. And once he gained, suppose I am doing it as a student, I am doing a project in agricultural domain in second year, suppose second year, first semester, I understand the agriculture domain, what are the intricacies, and then I learn the process of understanding the problems in a particular domain. Some knowledge of agriculture is also required for that. And then such innovative the proposals are to be submitted for approval. So that is the first. Then next is identify and learn the technologies. Professor Dongre, our Dean Research and Innovation, has already told you what are the technologies required to address the problem of, say, leaf plucking, the tea leaf plucking to prevent snake bites, to protect the laborers who are working there. So the next job the student does is to identify and learn the technologies on his own under the guidance of the faculty. So this will also help him to learn on his own. So this creates a self-study culture within him. So I have given here some indicative list of technologies which the student learns. Data analytics. It is not necessary that when I teach a course on data analytics, then only the student should do course projects in data analytics. No, even a first year student chooses a project which requires data analytics tools. And then he learns the basics of data analytics. Then additive manufacturing, blockchain, robotics, machine learning, artificial intelligence, cloud computing, MEMS, Zigbee, IoT, industrial automation, cyber security, data science, 3D printing, mechatronics. Again, mechatronics is one of the courses which we are offering common to all the branches. But a student, even if he has not learned the course, before that, if he needs to use mechatronics technology or mechatronics knowledge to put the project in practice, he learn on his own. Composite materials, virtual reality, AR, VR. So these are the technologies the student learns. So this is the theme. Then now the technology is there. Suppose computer vision is identified or machine learning is identified. No, I need to put that technology in practice and address the problem in that domain. So continuing with the leaf plucking project. So tools, what are the tools? So it's a very well-known tools. Java is there. So the student in the first year, suppose he is given this project. Now the leaf plucking project is done by second year students, and there is a mix of chemical engineering student and one thing I forgot to mention, that in this project-centric learning, student from first year to MTech, student from chemical to computer to mechanical to industrial to electronics, anybody can form a group. It is not necessary that student from computer engineering has to come together to do this project. It is mix of all branches, mix of all years. And sometimes the younger students are good at one thing and the senior students are good at another thing. So they make a good team. And that is what happens in a corporate world. It is not that all the project team members are of the same level many a times. No, they are of different levels. Some is senior, some is junior. So Java, so the student, if he is doing this project in the second year and if he has not learned the Java, he cannot say, sir, I cannot solve this problem because I don't know Java. No, you learn Java. And there are enough number of MOOCs available, like Coursera and other platforms, even VIT platform EduPlus now, there is Java available, and our faculties have also developed MOOCs, which the student is given right to access free of cost. And the student learns Java, and if any problem is there, the faculty is there to advise him, who is the project advisor. C++, then 3D Experience. Just to mention about 3D, the Dassault system has donated us 1 crore of grant to us to set up this 3D Experience lab, and most of the projects, many of the projects are carried out in this Dassault system labs. Then MATLAB, then Skylab, SolidWorks, NS2, Python. And just to mention that Python is mandatory at VIT in the first year, first semester itself to all the branches, common to all. So students learn the Python so that later on they can master any other language, Java or any other. Then LabVIEW. Just to mention another thing, if a student learns certain other subject apart from that are required in the curriculum to be learned, mandatory for earning credits, there are baskets given and the student learns the courses from that baskets, and maximum 15 credits are allowed for him to be earned as an extra credits. Then Simulink, embedded hardware platform, Code Composer Studio, CATIA, ANSYS. So these are the tools the student learns. These are just indicative lists. It depends on which is the case study, which is the project, and what tools and technologies are to be used. This is an indicative list which is being done most of the time. Then a typical EDI project. Vijay Gaikwad. So I will request Vijay Gaikwad, the Dean Quality Assurance, to explain this typical EDR SDI project, which is there. Just before that, I will mention that if the project is based heavily on development work, software coding and development work, coding is not the main aim of this project, but the development of the software is the main emphasis, then it falls under the category of SDI, and that can be taken under that course. But if it is development of hardware and software both, then it is EDI.
So as director sir said, students group, they selects a case study of ship intrusion detection, and for that, let's say the domain identified by group of students under the guidance of faculty is a defense, and then in defense there are lots of problem statements that group can discuss with the faculty, and the faculty guides them, and based on that they identify and come up with one problem statement. After that, once the problem statement is identified, then a group discusses with the faculty that what technologies can be used to sort out this case study. And then as a part of the discussion, the outcome is computer vision and the deep learning. Both can be combined together, and with the help of these two technologies, this problem statement can be solved out. Then students understand that computer vision technology, deep learning technology under the guidance of faculty. And after that, this group of students, they implement the problem statement, the algorithm, the design approach with the help of Python tool as well as OpenCV tool. So Python and OpenCV can be clubbed together in order to provide a solution to ship intrusion detection using computer vision based approach. So in this way, a group of students, they find out a solution, innovative solution by designing a innovative algorithm with the help of proper technology and appropriate tools, and then they come up with the development of EDI and SDI. Thank you.
So again, the domain here, defense domain, the details of the defense domains is to be understood. What are the requirements? Then the computer vision theory is to be learned. Deep learning is to be learned. Python is to be learned if he doesn't know the Python, and so many things. And then he starts working on the project under the guidance of the faculty. Now, how we put it into practice? So a group of 5 students, it's mandatory that group of 4 to 5 students should come. In exceptional cases, 4 students are allowed if there are no other students left. So 5 students generally should do the project because it helps them to work in a team. So the 5 students work together, they approach a faculty. It is not mandatory that, this group is allotted to this faculty. It is left to the student to approach a faculty. Then the faculty then assigns the domain and a case study to the student based on the choice of the student and the expertise of the faculty. So sometimes the expertise of the faculty is taken into a consideration. Sometimes the choice of the student is taken into consideration. Sometimes both, if they are matching. Then such a faculty will mentor 5 students group. So 5 groups, I mean, group 1, group 2, group 3, group 4, group 5. And each of the case study which is assigned by the faculty can be of the same domain. So suppose I am a faculty, I may give all my 5 case studies or project-centric learning in defense, or I may give them in different domains. So one in agriculture, one in defense, one in green water, one is in smart city, healthcare, like that. So once that is done, the student learns the domain knowledge. Substantial time is spent on learning the domain knowledge. Then he identifies which theory is to be learned, the technologies are to be learned, then which tools are to be learned. This is what is typically carried out in the final year most of the time. But there also, when I was a student, I know, and some 5, 7, 10 years back, I know that student says, sir, I have not learned this course. Suppose a mechanical student is there, he said, I have not learned machine learning, so I will not do a project which is based on machine learning. So here, machine learning doesn't come into picture. So the problem statement is the priority. And then whatever is required to solve that problem statement, I need to learn. Then it may belong to mechanical engineering or a computer engineering course. So the tools, technology, and domains, and then documentation is done on VIP, Vishwakarma Online Learning Platform is there. We have specially designed, our faculty have designed 2 platforms, VOLP, Vishwakarma Online Learning Platform, and VIERP, Vishwakarma Institute ERP Solutions. So everything is on these 2 platforms, right from our registration to our results, right from our projects to our MOOCs, right from our PPTs to attendance. Everything is on these 2 platforms. Then the student is supervised by 2 faculties. One is called as the faculty supervisor, which is the main faculty, which is accountable to that group. And there is a multidisciplinary, MD stands for here a multidisciplinary supervisor, because sometimes multiple tools are to be learned. Some may belong to mechanical, some may belong to computer engineering. In that case, the other faculty is from the other domain. And then meetings are scheduled regularly. Weekly reviews are done by these two faculties. I have given a substantial slide to that also. Then midterm review and the external end semester assessment. So the process is like this. Group formation is done. The group selects the domain, the tools, the technologies, learns the tools, domains, and technology. They design the problem statement. They address the problem statement through a design. They develop the project, and they thus propose an innovative solution. Then that innovative solution is demonstrated. It is assessed by the externals, and a report is generated. But report in VIT is not like a normal report which is of 100 pages. It is in the form of a publication, and it is IEEE standard format publication. Everything is known to the student in the first year itself. There is a course in first year, we call it design thinking. A design thinking course is given, and also a course on research and innovation. A special course of 2 credits on design thinking, another course on research and innovation. There the student understands how to write a paper, which are the best journals, which are the top journals, what is SCI index journal, what is what is Scopus index, what is H factor, H index, what is innovation, what is research, what is the difference between innovation and research, how to do literature survey, how to write a paper, what should be the format, what should be the font size, everything, how to write the paper, what to write the introduction, the body, conclusions, results, discussions, everything. That is taught to the student in the first year itself, in the first semester itself, so that they are ready to do what is patents, how to file patents, how to have startup, what is the process to have startups. Everything is taught to the students in the first year itself. Then the internal and the midterm review are carried out. We call it the internal review, the midterm review. The midterm review is after the 8 weeks of starting. So it is carried out by the department head, the department coordinator. There is a case study based or project centric coordinator in every department, the dean academics, the dean research and innovation, and dean quality assurance. Here the faculty supervisor doesn't come into picture. Faculty supervisor and the multi-domain faculty reviews every week, but here they doesn't come into picture. Then weekly reviews are carried out by the faculty supervisor and the multidisciplinary supervisor, and the external, that is end semester assessment, which is the formal summative, the final summative assessment, is carried out by the faculty supervisor, both the faculty supervisors, or multiple if there are more than 2, an industry expert and an external academician. These 3 carried out the assessment. And what is the pattern of assessment? This is very interesting. So we have put in so many years to design our assessment scheme. In VIT, there is no one examination to give grades to the student. For example, I will explain this. If physics course is there, normally the marks of the physics course are based on a 3 hours closed book exam hall, exam which is carried out in a hall. So a 100-mark paper is given, and how he answers, he gets 70 or 60 or 80 marks, and based on that grade is translated. No such assessment in VIT. There are many components. 15 components are there for any course, and the faculty select some of them, 7, 8, 9, and the assessment is carried out in every component, and the choice is also given to the student. For example, in data science, the student may select 7 assessment components, and another student may select not these 7 but different 7. So not only in VIT we have designed your own degree, it is design your own pedagogy, the way you learn, the design your own assessment also. So project components I will explain to you, this project centric survey, how he carries out the survey in that domain, how he identifies the problem statement is done. Then an MCQ, regularly an MCQ exam is taken by the faculty supervisor to understand his grasping of the domain, the tools and the technology. The design is carried out. A presentation is given by the student regularly, and at the end also they regularly carry out group discussion, and at the end also a group discussion is carried out in front of the external to discuss how they have developed the project in a group. Then blog writing, they need to write a blog on that. Then demonstration of the project, a comprehensive viva voce of the project is taken. Then publication is done by the student on that, which I just mentioned. I will elaborate on that also, whether he has won some awards on that project, and whether he has filed patents, and whether he has converted that into a startup. So marks are cumulatively added for one component. Award, if he gets the award, he gets additional marks. So in VIT, no student will get no A plus grade unless he gets either award, a patent, or a startup. So outcomes. Now every semester there are projects carried out. As I told you, around 9,000 projects are carried out. There are some of the project-based learning projects, and there are some of project-centric learning. So this is the data for the last semester, just which happened during the COVID period. 1,812 projects were carried out by the students. And how the assessment of the projects is done, it is through a conference. A conference is carried out where industry experts are invited and academicians from IIT, NIT, and other government colleges are invited, like COEP or any other good colleges, good academicians are invited, senior, and they combinedly assess the papers and the demonstration which I just mentioned, these on these lines. The assessment is carried out and the student presents the paper. So 1,812 papers were present based on EDI, only EDI, and parallel sections were 192 which were carried out. And this is the throughput, research throughput, which is only through EDI and SDI project, not MTech project, not PhD project, not funded projects in VIT. It is only through EDI, SDI projects, which is project centric. 182 journal papers, 256 conference paper. These are the first year, second year, third year students. 34 patents, 2067 projects, and 6 startups have been converted. Of course, startup, more students can go for startups, but the issue is that it needs some funding. So we are looking for sponsors for this. We are requesting industries also and some others also to fund this. We are, if anyone has any contact, please connect with us also to help us in this. Now, evidence of success. So in the evidence of success, I will request Dr. Vijay Gaikwad and Dr. Dongre sir to explain this.
So thank you, Director sir. So as mentioned by Director sir, every year our college students are doing the projects as EDI projects as well as the SDP project. So last data, if you see, 1,892 projects have been carried out, and we are conducting this one-day event as a student conference. And we are inviting the industry experts to give their critical reviews about that project. Also, they will give some opportunities that where they can launch it as a product, which type of companies they can look for, and what type of supports they can get for that project to convert it into product. And just to have some evidences to continue with the theme of agriculture only, because it is better to have the same theme to continue, because we have done a lot of projects in multiple domains. As sir has said, that healthcare domain, smart city, the water resource. So we are conducting the projects in every domain. And one of the requirement of the project selection is that the domain has to be socially impact. So whatever the technology we are using should have the impact on society or the social problems. So we are going to select a project only we will have the social impact of that project. So that is one of the benefit of the projects that are carried out by our students. Now this is one project which is started by the UPL funding, that is the United Phosphorus Limited funding, that is a seed sowing machine. Actually, we want to develop a robot which can do the seed sowing. So which will do the seed drilling, then it will do the seed sowing, then it will apply the fertilizer of particular amount, then the soil and some water. So that total activity will be carried out with unmanned activity with the help of the robots. So how it can be done? So we have started with a simple model. So we have started with some manual model, so that everybody cannot afford the big robotic system. So we have started with a simple model of a seed sowing machine for a smart agriculture. So you can see this model. So very simple model done by our first year engineering students. So they have done this seed sowing application for the smart agriculture. Then we have converted, we have used this idea and we have made one robot, which is the seed sowing robot. Now this robot is a sophisticated one, which is having the various types of controls. Like there is a seed drilling mechanism is there. There is also a seed sowing mechanism is there, and the fertilizer supply of a particular amount. And these all activities are carried out unmanned, means there is no need of a manual intervention for this. Everything is programmed. And this type of robot we have made, and our project has been successfully implemented. Now we want to just do the scaling of this project for bigger fields. So we have proved the idea, we have proved the feasibility of the project. Now see, Just we are taking one project and we are converting it into some type of products. Now, just to give you an idea of one more thing, so I think you can see this animation. So our students now are developing a complete 6-leg robot which can move in the muddy fields, which can move on any levels, because that is again one problem, because you will not get a plain surface in a farming. So you will have a robot which will have the balancing, it will have the self-supporting type of nature, and also it will do the plowing application, the seed sowing application. So our students have developed this type of a design which is patented again, and this type of design is used for the seed sowing. Now again, I will add some 2-3 problem statements here. So one problem statement they are given is the weed control. Now we know that what is the weed? That is the unwanted plant. Now this weed control means removal of the weed, that is unwanted plant, is very difficult activity if you do it manually. Because every time we have to see that which one is wanted, which one is unwanted, and then we have to have experts in that, and then they will do the removal of the weeds. Then we are doing it manually. Now if you see a simple plant of soybean, if you want to do the weed control, the soybean, there is a very harmful if you want to handle it by hands. So that type of thing, there are some grasses which are also harmful. So can we do some automation in that? So we have developed a weed control project also, which is again a completely robot is doing that weed control. So now, what are the technologies which are involved? Whether it is a simple problem? No, it's a complex problem solving. So what type of technologies are required? So we required the machine vision system again, because we have to identify which one are the wanted plants, which one are the unwanted plants. And then how to remove the weeds. So we have 3 technologies to remove of the weeds. One is by using the manual thing. So we have the robot which will pluck that weed plant. The second thing is by using laser. So we are burning that weed by using the laser. And the third thing is by using the chemicals. So we are spraying the chemicals and we are removing the weed. You see, our students are operating on the different types of challenges, and they are coming with the different types of solutions. Maybe one of the solution the UPL may adopt for their automation in farming. Then there is one more type of activity, that the seed drilling is the one of the activity. So seed drilling activity, we require the mechanism for the seed drilling. So we have to design it, we have to model it, and we have to do the analysis of it. So our students have done the design and modeling, and also the analysis by using the ANSYS software. So it is not a simple job. Even for experts to make a design and modeling and analysis of this type of mechanisms will be difficult. But our second year and third year students, we have to proudly say that they are getting this problem statements, which are of companies problem statements, which are live problem statements, and they are working on it and they are doing it successfully. Now, one of the problem statement I will just explain over here. That is a fruit plucking, just to continue that. So we have done the 2 projects there. One is about the apple fruit plucking. So we have to pluck the apple from the apple tree. So without damaging the fruit. Also, we have to select the fruit which has to be plucked. So that also requires some intelligence, artificial intelligence. So we are doing that. And then one more thing, that is a strawberry plucking. And strawberry plucking is more complex than the apple plucking. Now, how it is complex? The strawberries are generally, it is hidden inside the leaves. So how to identify? Because if it is available on the tree and we can get the picture of it, and then I can do the image analysis and I can do the analysis for it. But for a strawberry, it is hidden inside the leaves. So how to get that image? How to make the judgment that which strawberries to be plucked? So that type of projects we are doing, and that type of complex problem solving we are doing. I'm just explaining here one example of a agriculture domain. Similarly, we have the different types of projects in different domain areas, like a healthcare, like a defense, like a different areas like a smart city. And we are proud that our first year students to final year students, they are working hard, and not only PG and PhD students, but the UG students. And we are proud to say that our UG students, and that to be first year students, they are filing patents. So last year only, our first year students, 18 patents have been filed based on this EDI project and the SDP project. And we are doing it successfully from last 7 to 8 years. We are using this EDI and SDP project concept, and we are successfully implementing it at VIT Pune. So thank you, sir, Director sir, for giving me opportunity. So I will also explain some case studies if required. Thank you, sir.
Thank you, Dongre sir. Now, some of the award-winning projects. some of the award-winning projects. Professor Dr. Ashutosh Marathe, who is our Dean Academics, I would request him to share the glimpses of some of the award-winning projects. Just a background I would like to give that last semester also, from January to May, our students carried out this case study, this project-centric learning and project-based learning. But in the middle of the semester, the COVID situation came. And out of around 2,000 projects which happen around project-centric learning, some of the projects we requested our students to drop their previous projects and divert their projects to COVID solutions. And more than 100 groups, they came voluntarily to drop whatever they have done for 1.5 months and came forward to do new projects which will address the COVID situation. And we submitted it to various authority, and these are the award-winning projects. So these are the awards won in last 2-3 months. This we are presenting. I will request Professor Marathi to present.
Thank you, Director Sir. This is like what they say, proof of the pudding is in eating it. So the practices of innovation that were sold, or those practices that we had carried out in the previous years, have all started giving us the returns. And as Director Sir mentioned, all these have really been a valuable contribution from our institute for tackling the COVID challenges. So I'm just going to present a few of the award-winning projects which have really been helpful for the societal purpose. And one of those has been the institute project has been a winner in the Samadhan competition. It is an MHRD AICTE mega online challenge called Samadhan. And the solution offered by this team of students from instrumentation, guided by one of the faculty members, has won the topmost prize. And what they had developed was a SAM robo, that was a semi-autonomous multitasking robo, which is used for mass sanitization. So as far as our activities of COVID are concerned, they had to be non-contact activities. The human involvement was to be minimized. So this instrumentation team developed a robo, and that robo was extremely helpful as far as mass sanitization is concerned. Here is the demonstration.
I am from VIT College, Pune. We are participating in this hackathon with a design idea of SAM, that is semi-autonomous multitasking robot for mass sanitization. Our design idea is to create a SAM robot which can be used for sanitization as well as to help doctors and other people who are working hard to stop this pandemic. SAM robot is controlled using 2.4 GHz RC remote with a range of 100 to 300 meters. For navigation, we have used IoT-based camera system and a GPS module to get the exact position of the SAM robot on the monitor, as we are controlling our SAM robot from a long distance room. SAM robot is also equipped with a thermal camera which keeps on tracking people's temperature, as it is one of the symptoms for coronavirus test. This vehicle is also mounted with a robotic arm which can be controlled wirelessly from long distance by using our own natural hands, where a skull on hand helps to drive the robotic arm. This robotic arm would be also capable to perform different tasks to help the sanitization worker as well as doctors to provide medicine, masks and other requirements. The main work of SAM robot is to sanitize affected region of the COVID patient. It is equipped with two 60-liter tanks filled with sodium hypochlorite such acids which help in dissolving rapid growth of coronavirus. The spraying would be done using robotic arm, and its spray would be controlled manually by the robot operator. SAM is also mounted with a microphone and speaker to communicate with the people. So let's come together and help our country to fight this pandemic.
So that was about SAM, and it is extremely well received and is functional, which is a contribution thanks to our innovation-based projects. Our group was also a runner-up in the Atmanirbhar Bharat Hackathon, which is an MHRD AICTE initiative, and it was a joint activity of NPIU and Government of Gujarat. It was a proposed digital solution for the disabled persons, and we received the certificate. One of the students, Nikita, got this award, and the team Abhyuday had won this particular prize in the domain of e-governance and education. Also, the students have been contributing in variety of other humanitarian technology-based activities, and IEEE, as we know, is one of the leading international bodies. So IEEE had proposed Humanitarian Activity Committee competition called HAC, and our team has won the IEEE HAC site. Now site is Special Interest Group on Humanitarian Technology. They provided a blockchain solution for the combat COVID-19 concept, and the prize money is around 1,50,000 rupees in Indian currency. That is around $2,187 that the student team has received. So this was the team, our group of students from industrial engineering and other multidisciplinary contributors together proposed a blockchain solution, and that was well received by IEEE. So this was yet another feather in our cap, another proof that the innovation projects are bearing fruits, and especially during the COVID times when the necessity of these projects is at its premium. There was another contribution, an initiative by Google and MIT, that is Ministry of Electronics and Information Technology. Our team was in the top 3. The Vishwakarma Institute of Technology team featured in the top 3. They developed a mobile app for the hearing and speech disabilities, and they have used an AI-based mobile application which acts as a virtual interpreter and which enables a bidirectional conversation. So it has the ability to convert sign language into speech and vice versa. As you know, sign languages are equally important, and typically there are standard formats for the signs which are recognized and which are used, speech to sign language and sign language to speech. Using AI assistance, this activity has been carried out successfully. The activity was tested in our college, and as you can see, a student is making language gestures, and the other person is recording and then interpreting it in an appropriate manner. There is an application demo for the same, which I would like to present.
Let's say we have a user who is hearing and speech impaired. To use this app, the camera will be pointed towards the person performing the signs. The camera will then record the gestures, extract the key points and facial expressions while he is performing the signs, which will then be translated to speech in real time.
Did you do yesterday's homework?
Oh no, I forgot. Did you?
Similarly, when the other person responds, his speech will be captured and the corresponding sign will be performed by a 3D character called Harvey.
Yes, it was easy.
Can I borrow your book?
Yeah, sure.
Thanks.
In other scenarios, according to his convenience, the user can hold the phone in one hand and use the selfie camera to perform the sign.
Can you please guide me to the nearest medical store?
Sure. Go straight 100 meters and it will be to your right.
Thank you.
Let's.
So such are the demos, and so we were again a part of a non-stop online hackathon, 1 million second non-stop online hackathon. This was an initiative of Telangana State Innovation Cell and Telangana Information Technology Association and Publi Sutra, that was the agency. Advanced automatic sanitization helper, that was something which our innovation team produced, and it is used basically for sanitization and sterilization of the COVID wards, and it controls temperature and humidity of the COVID wards. So all these are the automatic methodologies which are helpful, and our innovation projects are mainly instrumental for making these things happen. Without ash, the workers would have to clean the isolation wards manually, putting themselves to risk. Maintaining the distance at times is difficult, knowingly or unknowingly. The proximity is compromised. Vacuum cleaners and other floor cleaning machines are costlier. No information about the temperature and the UV sterilization also could be a challenge. But with ASH, the automatic cleaning will take place, the distancing can be maintained. This solution, being an original solution, will be a cost-effective solution, much cheaper than the other machines. Providing temperature and humidity control is also possible with the help of applicable sensors, and the UV sterilization also takes place. So the innovation in one way would create prototypes. Those prototypes are tested within the college environment with the support and guidance of the faculty, and then those are deployed in practice. So just as the COVID times called for innovations, our VIT team has responded with innovations. Now I would request my colleague, Dr. Vijay Gayakwad, to please continue and conclude with the further presentation details. Thank you.
Thank you, Dr. Ashutosh Marathe, sir. So this was a feedback that has been given by the doctor from that particular state, High Hospital.
ఈ కన్సల్ట్ అనేది ఒక ప్రోగ్రామ్ అందులో నేను పార్టిసిపేట్ చేయడం జరిగింది. ఇది ప్రపంచవ్యాప్తంగా ఉన్నటువంటి తెలుగు వారందరికీ కూడా ఈ కరోనా వైరస్ టైంలో వాళ్ళకు మనోధైర్యాన్ని ఇవ్వడం కోసం డాక్టర్లు ఇన్వాల్వ్ చేసి వాళ్లకు కన్సల్టేషన్ కౌన్సిలింగ్ ఇప్పించడం అనేది జరిగింది. ఇది చాలా మంచి కార్యక్రమం. ఇంకొక ఇంపార్టెంట్ కార్యక్రమం ఏంటంటే టీటా మరియు తెలంగాణ టీటా.
So this is the certificate that Mr. Shivam Pali, a student, got from the Telangana State Innovation Cell and the team. I'm happy to share that a group of students, they got first rank in NAAC-India Adathon, which was the National Institute of Engineering, where the students they developed the safe and hygienic delivery of online ordered items. So in this pandemic, this online ordering is of a great significance, and this is a simulation design which got them the first rank in the particular competition. This is a certificate of Swapnil Mane, which has been received from the IEEE. One more event, one more initiative by IEEE Spain, IEEE R9, where a group of students, they developed a robot for data collection, the analysis of the data, and based on that, how unit sanitization can be mapped out. So it is used in the COVID wards to effectively deploy the mass sanitization. And again, glad to share that we are ranked amongst 5,000 teams all over the world for this particular innovative idea. And these are the certificates that we have received from the IEEE R9 for this robot for mass sanitization. And here you can see on the right-hand side some funds that has been received for a group of students. This news has been highlighted in various leading newspapers of the state, in the local newspapers as well. Then another success we have got in IEEE India COVID Move, which was organized by IEEE Hyderabad and IEEE Bangalore section, where again a group of students, they come up for automatic sanitizing helper in the COVID hospitals. So this helper helps in avoiding the obstacles. They get mapped and it automatically carries out the sanitization based on UV concept. This is a certificate of the appreciation. Then as a part of SDP project, a group of students under the guidance of faculty, they developed the virtual farmers market. So the farmers, one of the group who are badly affected in this pandemic, and they could not move from their local place. So 201 farmers, they got benefited out of this software defined project, software design innovation idea, and more than 30,000 customers, they got help in this particular service of virtual farmers market. 1,002 tons of delivery has been completed with the help of this app, and a revenue of 1.96 crore has been generated. The students also worked on the blockchain technology management to combat this COVID-19, and they helped one of the NGO in the city so that whatever distribution and delivery of PP kits, sanitization and masks, that happens very smoothly and very systematically with the help of software project. Then another group of EDI project and the SDI project, they assisted the senior citizen in the doorstep delivery of the groceries, vegetables, and the medicines, and even they can call the doctors as well. Another group of SDI project, they developed a software-based tracking system which helped the Kolhapur district to deploy a tool based on the data analysis to track the returnees. So whoever comes back to the Kolhapur in this pandemic, once the lockdown has been declared by the government, then all those returnees data can be collected by the Kolhapur district corporation, and then based on that data, they could achieve some kind of conclusions, and they can take some action, they can carry out some measurements. Then as a part of EDI project, another group of students, they developed the food operated sanitizers and they donated it to Karambali Gram Panchayat. So these are some success stories that has happened as a part of EDI and SDI.
So we are really thankful to all our inspirators, our stakeholders who guided us, our industry partners, our students, our alumni, our faculty, the academicians, our governing boards who have given us this innovative idea through our discussions and deliberations and churned out the interactive and experiential based learning for cultivating innovation among the students. And this was the reason why our students could, any competition you announce or any project you tell them, they will say, they won't say that I don't know anything of it. They say, yes, I will learn whatever is required to address this. And this was the concept of our project-centric learning, our EDI and SDI project, Engineering, Design and Innovation, Software Development and Innovation. So it was a great success. And lastly, I would again like to thank NAAC authorities, Kamble sir and Madam Leena Madam and others. So for giving us this opportunity, of course, the chairman sir also for giving us this opportunity to present our best practices. And I hope that we could do justice to what you are expecting from us. Thank you so much. And we are now open for discussions.
Thank you, Rajesh ji. It was an excellent, I think so. As soon as you were going through the presentation, so many questions were there in the mind and the presentation was going ahead and automatically the questions were answered in them. So it is fantastic. Means you and your team are doing a fantastic job. There are still things with me for you to ask, because especially the things what you have mentioned related with the primary skills. There are 11 number of primary skills what we have learned. I just remind my college days when I used to do MBA, that specific skills being adopted by the or required by the corporates. All those specific skills required by the corporates, you are adopting that 11 skills you have mentioned. In addition to that, secondary skills you have talked about, that all among around 18 are there, I think so. I have counted it very nicely. So nice elaboration. I think I have my colleagues to comment on that. Dr. AKR sir is there. Ratha? Okay, no problem. Let me just ask Dr. Samuel. Samuel ji, is anybody there to ask the question?
Yes, sir. There are a couple of questions.
Yes. Please allow. I would request them to.
Dr. Monish.
Yes.
And Roy. Sir, go ahead. Okay, go to the next person. Pradeep Chindi. Pradeep Chindi. M. Rajendra. M. Rajendra Prasad. M. Rajendra Prasad.
Can you hear? Yeah, sir.
If you have any question, you may ask the question.
Sir, good evening, everyone. And this is Mr. Rajendra Prasad from Vidya Jyoti Technology. First of all, many congratulations to because at the first year level, I've seen many patents were applied and published many papers. So my question is like this: I would like to know the best practice that is about the project-based learning. Have you linked with the curriculum? There's a curriculum that you have, or else like you picked about the courses and or like is there any relation to the particular course like data science and artificial engineering? Just I would like to know this question, sir.
project-based learning and project-centric learning. That's your question, sir?
Yes, sir. Yes, sir.
It is a part of curriculum. It is so. Instead of learning subject 1, subject 2, subject 3, subject 4, they learn 3 project-based courses, 2 project-centric courses. It is like this. So instead of learning physics course, they learn a project which may involve the knowledge of learning physics. It may involve learning physics, knowledge of physics, and other courses also. This is an example. So there are 20 credits in each semester, and there are 5 courses. Each course of 4 credit, 3 project-based and 2 project-centric. So I hope I answered the question.
Yes, sir.
Based on this project work, they get the grades, and based on that grade, they get the CGPA or SGPA.
We go to the next person, Suman Devi. Suman Devi. Suman Devi, do you have any question?
Hello.
Yes, ma'am.
What are the effects of emotional intelligence and cultural on cultivating students' innovation?
Achha. So I repeat the question. What is the effect of emotional intelligence on cultivating the innovation in students? Yes.
Yes, sir.
So what is emotional intelligence? Emotional intelligence is the ability to manage one's and others' emotions. Because in a given team or in a given family or in a professional team, there are people who sometimes have some emotional issues. I won't say issue, but they have their own emotions. So in order to manage the team properly or manage personally, we must have learned the ability of managing our emotions, and that is the emotional intelligence. So when we are talking of innovations, how the innovation will come into action? Innovation will come into action when we have compassion for others. Of course, innovation will come with a motivation of generating revenue, generating funds. Definitely, that's one of the key reasons why people do innovation, why people do projects, why do people have startups. But other, which should take priority in normal case, is the compassion, empathy, kindness for others. And when we have that emotional intelligence, and when we learn to understand the other emotions, for example, let us take healthcare. So many times it happens that a person whose family member or a dear one has died due to heart attack. So he becomes a charitable person, and then he starts a hospital, and he said this is a cardiac center, and the treatment is given free of charge, like that. So that is of course one which is done for for people who can donate money or who can give money. But for a technologist, for a engineer, for a person who can work with technology, for him the greatest emotion he can show for others is developing those technology which will solve the problem. So therefore, and such will give impetus to innovate things. So there is a definite relation and a relation between ability to do innovation and the emotional intelligence. Ma'am, hope I answered the question. You have any further questions on this?
No, sir. Thank you so much.
Yeah, we go to the next person. Yeah, Maja.
Yeah, good evening, Doctor.
Good evening.
Very good, excellent best practice are following. I have one question. How many hours you have allocated in the curriculum for the project? And another question is, as you have mentioned in the session that all the projects are done in a multidisciplinary, the multi-years of students will be there in a team. How is the grading is done to the students? If the grading for the first year student and second, third, if you are in the group, is done equally, or the credits also assessment? How is the assessment done?
Yeah. So I got the question, ma'am. It was not audible initially, but later part was audible properly.
Yeah.
The question is, when group, when students from different groups, they work together on a project, how the grading is done? Is the grading done with consideration to their background, right?
Yeah.
That is what is your question.
Yeah.
A student belong to first year, belonging to chemical engineering and doing a machine learning project, no consideration is given. No, the project is evaluated totally on the merit and the contribution.
No, suppose if in a team, different students are there. And what is the assessment procedure you are following, sir, for grading the?
So that I have explained you, ma'am. So there are various components. One is the how they select the domain and the case study. For that, what kind of survey they do. Then what type of design they carry out. What is the design procedure they carry out. Then how they answer the weekly reviews. How they give the presentations, the mid-sem presentation, the end-sem presentation, the weekly presentations. Then how they perform in the demonstration, whether the project is demonstrable, workable, and what is the quality of the project. Then how they answer the questions on that Viva Voce. Then also based on they are supposed to write a blog on that. So unfortunately we cannot bring the blog. They have to write a blog, say I have done this project, a small blog, a technical article on that. So that improves their writing skills also. So the blog is displayed as a poster, and the poster is being assessed by the industry along with the project demonstration, and then they find out. And we also ask them to post it on the social media. Then whether they have participated in any competitions. Competition carries certain marks, winning the award carries certain marks. Of course, award winning, we don't give much credit because see, everybody cannot win. If 100 students are participating, everybody cannot win. So participation is also given. Then whether they have converted that into publication, how the report is written, which is in the form of a publication. So it is 4, 5, 10 pages, not 100 pages. So the quality of that work is assessed. The presentation which they give in the conference, the EDI conference, that is also assessed. Then whether it is published in the outside journals, conferences, that is also taken into consideration. Whether they have filed the patent also, and whether they are making up a product, final product, and whether they are converting it into a startup. So weightage is also given to that. And sometimes, not sometimes, the option is open to all the students to carry out the project from first semester to eighth semester continuously doing the development. If I take a project in the first semester, I can continue it the second, third, fourth with the permission of the department.
So just wanted to add to what Honorable Director Sir said, that along with that, at every stage, there will be people from industry who will be judging this. So therefore, this makes it very rigorous. So we'll have multiple project reviews, and every time, many stalwarts from industry, they come, and then they will be judging these projects. So the assessment is very robust along with that. So just wanted to add this. Thank you.
Thank you very much.
Last question, Dr. P.K. Chidambaram. Dr. P.K. Chidambaram. Dr. P.K. Chidambaram, you have been unmuted. You can just speak up now.
Okay, next.
Mohammed Arshad. Mohammed Arshad, you have been unmuted. You may ask a question.
You have been project-based learning in engineering. What are the humanities courses? How you are doing your practices, sir?
Can you repeat, sir? Because the first part was not audible.
Sir, you were explaining that for engineering students, you are doing project-based and project-centric teaching and learning process. How you are handling the humanities courses like MBA and other courses? What are the best practice you are implementing in your institution, sir?
Okay, got it. So I will take you I will give you an example of, we have a course in the first year, Humanities and Social Sciences, where we teach them sociology, psychology, and philosophy. So you are asking how we are handling that. So that course comes under project-based learning, because it's a course. The title is given. Suppose we say physics course, we say chemistry course, we say biology course, then they becomes a project-based course, because the theory is taught in the class and a project is being carried out in physics, chemistry, and biology in the laboratory. Then two courses are where the project is given and no theory is taught. The student need to identify which theory they need to learn, and they have to learn under the guidance of the faculty. So humanities and social sciences course where psychology, sociology and philosophy is taught, it comes under project-based learning. So for that, how we carry out the project, there may be some questionnaire. Like for example, I will give a very gross example just to make it understandable. Then suppose in psychology, the question may be, a survey may be given to the student in the form of a project that arranged marriage versus love marriage. What are the pros and cons of arranged marriage versus love marriage? And they go to hundreds of people or hundreds of students. They find out their opinion on that. Or the survey may be joint family versus nuclear family. And some questionnaire, they design a questionnaire on that. And then based on that questionnaire, they design the questionnaire so that the quality of the questions decides the quality of the project. And the answer they do, and they do the data analytics on that, and they present the conclusions. Would like to add, Marathi sir? Marathi sir would like to add.
In such courses, there are other courses because the curriculum and the syllabi is well defined. Let us say the similar courses are, let us say, stress management. Whenever a student comes, typically nowadays the scenario is that we would get students from Mofussil areas, and then we'll also have students from abroad as well. So there is a wide cross section of students, and everybody is experiencing the intricacies of engineering for the first time. So there could be a project that we consider that it says stress management or adjustments, because it's not only these 8 hours the students would spend in the institution, it is the remaining 16 hours that the students spend, which are typically unknown to the faculty or the organization side. But those 16 hours are equally important. So what kind of stresses the students experience, let us say outside campus, if they are first time arrivals in a bigger city like ours, then what are the urban challenges they are facing and the adjustments they have to make is yet another topic which is considered for such kinds of activities. So we find out activities and events of relevance and interest and carry out surveys and projects in a scientific manner.
There's one more thing that I'd like to add. Regarding the hands-on, we have a special course called, general proficiency. And, we ensure that the students do various types of social service also, because humanities, social sciences courses are there, that's only theoretical. But we ensure that our students do various types of social activities. In those social activities, our students go help the traffic police. They even go to very underprivileged children of prostitutes, like that. So it's not that they're just doing theory, applying it in very realistic sense. Working many hours on this for social service, and it is a part of our credit system. So social service is also a practical aspect, implementation of the study of human values and social sciences. Yes.
Just to continue with what Dr. Vaikwar was saying, social service of 40 hours is mandatory for every VIT. And how that will help to cultivate that empathy factor. Kindness, compassion, and empathy. These are the 3 different degrees of kindness. Empathy being the highest.
Go to the next question. Someone,
Yes. Good evening, sir.
Good evening.
Good evening. Thank you very much, first of all, for a very wonderful and insightful presentation. One small question, but very basic question for us to understand. What is the teacher-student ratio in your institution? That speaks volume.
Sir, we are an autonomous institute. So for AICT requirement for us is 1:15, and we have a 1:15 student-teacher ratio.
Okay. Thank you.
Thank you, sir. So this question I will tell you definitely. Because many of the delegates who visit VIT and we present to them, they say that teachers' load must have increased now. So it's a very relevant question and very apt question, and thank you for asking this.
That's it from my side, sir.
Thank you, Dr. Rajesh, for answering the questions very smartly. You are a very smart leader, intelligent leader, I think so. And yeah, it is very easy to judge. It's very nice. I have a few questions related with the presentation, what you have. Of course, what I have seen is that you have some 17 relevant technologies with 14 relevant tools. And around you have presented some 16 case study domains in various areas, including agriculture, healthcare,
You have
defense.
noted it very, very nice. You have noted. It would
No,
be
yeah, that is my
forever.
business. Of course, that is our business, because we analyze the institution all. We have completed around 80. This is the 18th one, and we see how it's performing in their business. Yours is an exceptionally very good. Something very interesting I would like to ask here, sir. Our contribution, because of course institution matters, their output matters for the nation's growth. So contribution from agriculture to our economy is around 15%. And recently in our parliament, you might have heard, it was very much in news, 3 bills on agriculture market reforms has been passed. It is all to bring lots of strength to the agricultural sector. As a technical institution, what is your contribution? Of course, you have some things you have stated related with some innovation created. For example, virtual farmers market, what I have seen, you might have also gotten as an input 1.96 crore, what I have seen it. But as an institution, in a long-term aspect, because our country is really facing this one, majority of population, that is 60% plus population is based on agriculture sector, directly or indirectly. How your institution says into this regard, in a long-term aspect? Please.
So your question is that how our institution plays a role in the domain of agriculture in long-term basis. That is what
yes.
your question, sir. So we are we were studying some week back. Just it's a very I am very happy to answer this question, that we are thinking of starting an agriculture and food technology BTech. Am I audible, sir?
Yeah, sure. It's nice. I think that is something. It is essential. Food processing units are like that.
We take in agriculture and food technology. So that another thing is that I would answer it in a little non-technical sense. Under the GP program, General Proficiency course, which Dr. Vaikar was mentioning, we form around 1,500 students. They participate in 30-30 group, a group of 30 students. So that becomes around 50 groups. So they visit the different villages around Pune city. And even I have told the students, our team has told the students that you go to your local places. Somebody is from Latur in Maharashtra, somebody is from Nagpur in Maharashtra. And there are issues of the farmers over there, not only in terms of adopting technology to use to the agriculture, but also their basic needs. So our students are helping the farmers for their literacy, for how to increase the agriculture produce. Another thing, I think Dongre sir has something to add. He is indicating me, so I will request Dongre sir to.
So as sir has already told that we are planning to have a course in a BTech, but next year we are going to start with the elective stream in agriculture engineering. So already we have started one course, elective course as agriculture engineering, and one of our member from the UPL, he is contributing the syllabus formation and he is taking some expert lectures in that. So we are going to start from the next year the stream of electives in agriculture engineering, like IoT for agriculture, then agriculture economics and the economic analysis. So financial management aspect is there. So that type of projects that type of subjects we are going to offer to the students, such that those who want to become an entrepreneur in the agriculture field, they can become entrepreneur. Because most of the students, they are coming from the rural background and they have the farming land. Only thing is that they are not utilizing it to the maximum extent. But as you are rightly said, sir, we are also thinking about this. And in the coming future, we will be having one BTech course. But in the next year, from the next year onwards, we are having a elective domain. So where the number of electives will be offered in that. And already we have started in that.
I would request you, sir, to also suggest us, give your input to us. If you have any experience in this, we would be love to interact with you and have you also on our board, wherever you feel help us.
It's of course so nice of you. Yes, I said you are very smart enough to answer the things. No. That is you have a wonderful team. One more related question I found that I should just.
आपल्याकडनं प्रॉब्लेम नाही
आपलं ते दिसतं ना.
नाही तो असंही दिसतं. Hello, we are not able to hear. Is it problem?
No, 1 minute, sir. Actually, my laptop got switched off, so I have now joined Dr. Leena Ghane's madam's laptop. Yeah, that's very important. Can you hear me?
Yeah, we can hear, sir. Yes.
Yeah. So all thanks to Dr. Leena Ghane. The important question is regarding the patent. Sir, we in our India in 2011, it was evaluated some 5,170 patents were there at that time. Okay, this is something very interesting. And compared to the first, in the first ranking, Japan was there with 2,74,170, and I think so China. Yeah, China is third, 1,72,000. USA is second one with 2,72,000. It was in 2011. Now in 2021, again it will be evaluated. I have seen you have few of the patents in your credit, and in I think so in the first year, students have also come out with 18 patents. My question is, again, short term, long term, both the aspect, because our country is really suffering in case of innovation, creativity. In our NEP also, we have come out with that concept that we should push higher education institution to think into this direction. How your institution is doing a marvelous job as per the presentation, what you have done today. How your institution is helpful in making our country very good in case of innovation, creativity. Let us relate with the patent, please, sir.
I have probably understood your question, sir. So as I told you that the purpose of starting this EDI or SDI concept, this is a case study based approach or hands-on, was that why India is definitely behind the other countries, and you quoted nicely the statistics from Japan, USA, and we did this study also some 3-4 years back. India publications, patents, and the conversion to products and some useful application is missing. So we said that, of course, VIT has PhD program, MTech program. Our PhD and MTech students are there, but limited. Around 60 students have registered with PhD. But we noted that in VIT, the BTech students are more smarter, with no offense to anybody, to the master and PhD students, but our BTech students, they are the cream, and they are top ranked students. And also, as I mentioned at the start, that if the nation has to come up with more patents, meaningful patents, I don't mean to say that only theoretical just for the sake of filing the patents, just they're converting it to startup and successfully running the startups in long run. So we got this concept that why not to cultivate this culture of innovation among the students right from the first year. And we made it mandatory for all the 1,500 students. We have 1,200 intakes, and some foreign nationals and some other diploma students also joined, 10% now, earlier 20%. So around 100 to 1,200 to 1,500 students, we made them mandatory. And we realized that not all 1,500 students are good at innovation, because different students have different skill sets. But those who are very, very smart in that domain of innovation, startups, publications, patents, and commercializing the product, we have identified them, and we have an EDC cell, Entrepreneurship Development Cell, headed by our professor, one of the professor, Dr. Dhake. And what we have done is that we had an internship mela every year in February. Of course, this year we could not have because of pandemic, but it was delayed also. So every year, February, March, we have a internship mela where industry comes. Which are those industries? These are the startup industries. And they give internship to the student in the summer, and not on technical topic, but the topic is on how to have a startup, how to do innovation, like that. So our contribution in small way at present is to introduce all the students to the science of innovation, the art of innovation, and evaluate themselves or do their own SWOT analysis in top innovation and find out whether they can explore in future. Those who cannot, that's okay, but those who can, they can become. And there are plenty of successful stories with VIT students who have become successful entrepreneurs in last few years only. And in long run, we are, of course, we have an incubation center which is very small. We would like to have a very big incubation center, and we will provide much more opportunities to our students to set up their small startups here. And also I would like to mention that Dassault system is helping us in this regard. Even Immersion is helping us in this regard to hire our students and provide facilities to our students on their campus to have their own startups. And later on, if it's successful, they can sell the startups to the companies. I hope that this is what you are looking for. If you want something else, sir, I can add to that also.
Yes, of course. I have a series of questions with you, but because of time frame, because so much of stuff is there for you to answer. So it is essential for the stakeholders also to understand. I think so they might be learning some new things from you, and that will be beneficial. That is an intention of asking so many questions. Two more queries are there related with your stuff, what you have come out with. You have said that a typical EDI, SDI project you people are running, and with almost 2067 projects, your students have done it. Want to know what sort of practical utility it has been benefited by that to the society in large. Please, sir.
Sir, Dongre sir would also add, because he is dealing with that research and innovation. Dr. Marathi is also Dean Academics. He is dealing. Dr. Vaikar, who is now on the other line, other laptop, other place. He was the Dean Academics till 2 months back. Now he is the Dean Administration, and Professor Marathi was Dean Analytics. He has taken over as Dean Academics. So the practical outcome I have already presented in the last few slides, where for example, I will tell you one of the outcomes is that there is a Pune Cantonment Hospital in the camp area. That SAM, no, that project name is SAM. It was semi-automated machine, a robot, which would clean the wards, the COVID wards, without a manual intervention. So it is deployed there. And also another part 2 of that project is that it will ask certain questions to the visitor, like what is your how are you feeling? It measures its pulse, it measures its temperature, other things, and sanitization also is done by that manually.
Okay.
So that is the practical outcome. Second is it's a very good question, sir. Because 2000 projects are carried out, I would like to honestly confess that not all the 2000 projects are of very high quality, because the student diversity is definitely there. But what we believe in is that after doing series of projects in different groups, suppose I as a student join first year. In the first year, I do a project in the with a certain group. Then in the second sem also I do EDI, SDP, SDI project. Both are mandatory in every semester. Then in the third semester I myself will personally improve from where I was. It's a incremental delta increment in my personal ability as a student. And I definitely believe, or we definitely believe, that over the year, he will get that confidence. Yes, I can solve the problems. Whatever social issues are there, I can identify them on my own. And even though I haven't learned in my formal education, I can still learn myself, because I have learned that the learning ability, the self-study ability I have, and the confidence I have, because I have solved such 7 case studies in every 7 into 2, that is 14 case studies in my life. Along with that, project-based learning is 3 per semester. So I have done that. So this will definitely help the student. But of course, there are smart students who do wonders, and they have a very prosperous career. I can give one example. The 2 years back, some of our students were placed in Microsoft because of their EDI and SDI projects, and they got the package CTC of around 53.4 lakhs. And they were placed in Hyderabad, 53.4 lakhs.
Good.
This
is a big one.
This is not the salary of all 4 of us taken together.
Yeah, and it's a big one.
Yes, you have Mohit Madhwani. What is his name? Student name? Mohit Makhija. He was in the Microsoft interview. He performed very well, and the Microsoft team asked him, "What is to what you credit your success? We have selected you. We found you very useful." He said, "It is, sir, because of our projects."
Excellent, sir. It's very nice that I have already noted. You have that 4 major contents as a practical approach: that robot for mass sanitization, that I speak free concept, that advanced automation, that ASH, what you have come out with, and already mentioned virtual farmers market. the thing, presence of mind, what you are having, I think so you are percolating to your faculties and students the way. So one thing you have mentioned here, this is the last question. You have mentioned in your primary skills, out of that 11 skills you have mentioned one very important skill which is a need of the hour, और वहां पे मार खाते हैं बच्चे generally, that is judgment and decision making.
Perfect.
Yes. Now you understood. You tell me how you are able to.
Your voice, you are not audible. Last part I missed. The judgment and decision making, I heard that. Later part I missed out.
Yeah, that is you understood the crux. Actually, that is the thing I like you about you the most. What is necessary that you understand. Decision making, how you are percolating the decision making ability among your student, because that is the need of the hour. वहां पर बच्चे generally मार खाते हैं. Where they are showing a poor performance in the life also. So decision making ability, how you are improving within them.
Yes. So I will just tell it in twofold way. One is that we have it. See, we are one of the only. First, I will tell about the faculty, because unless that ability is percolated among the faculty, decision making and judgment, that cannot be percolated to the students, because the student can be as good as the faculty. So what we do is we have a team of 22 faculty who are the leaders and top management of the local management of the institute. They are the deans and the head of the department. And we meet at least 3-4 times in a week for about 2 to 3 hours. And the COVID pandemic has helped us to meet out of the office hours, because there are no office hour constraint now. So every matter what we take, whatever decision we take in our institute, may be a simple matter or very difficult, challenging problem statement facing the institute, we discuss it, brainstorm it, deliberate it, churn it out in our top group. So every person will express his opinion, and when he expresses his opinion, every other member has the I would say openness to challenge his decision or to contradict his decision and presenting his own decision. And also we are the only college where there is a concept of assistant heads. So there is a head of the department generally. Suppose there is a mechanical engineering department, there is a head mechanical engineering, but there are 3 assistant head. One in admin assistant head, one is research assistant head, and the one is academic assistant head. So we have 9 departments. So 9 into 3 is 27 assistant head we have. Plus to the deans, there are 2 assistants to that. They are not assistant dean, but they are assistants to dean. And faculty also we train regularly. There is perhaps we are among the few institute where there is a faculty development cell headed by a dean faculty development, and various training programs are carried out. I will tell you, sir, you would be you will not believe, but 400 hours of training is carried out for faculty every year. Yes. This is not doesn't put. If I study my subject power electronics, do some MOOCs courses, that is not included in that. That is training, means it is under the supervision of an instructor. So 400 hours of studies is carried out, and then those faculty percolate that that ability within them of judgment and decision making to the students. So how it is done? There is a group discussion to every course. Suppose I will just take physics course. Suppose the physics course is there. In the physics course, there is a half an hour discussion every. So we have a tutorial concept. The physics will have a tutorial. The tutorial is not conventional tutorial of students solving some problems that they can do at home. Nowadays there are so many tools available, but we are inculcating the skills. So the group discussion is carried out in the class, and a group of 5 students are given a topic, and that topic is not given predefined to them. It is given on the spot, and then they discuss. So I think Marathi sir will add to that, because we have good experience of data science. So this how it cultivates in the decision and judgment, because he is teaching the data science and he can share some experience of data science.
So basically that students are made to play the role as a leader in case of a certain situation. Let it be a technical discussion in case of data science. Which of the classifiers would you choose and why? You are given 2 to 3 choices. One is a cost-effective solution, another is a time-effective solution. Given the circumstances, how would you choose a solution? So although this problem is technical, related to the data science algorithms, the learnings that take place are applicable to the general engineering life, so to say. So the group discussions are aimed at decision making. As Director Sir mentioned, every student undergoes group discussion. There is a case study approach in some generic subjects as well. So the decision making or being a good follower as well at times is percolated during the course of these assessments.
There are 9 group discussion a student will go through in a semester. and he will hear 2 9 5 or 45 group discussion in a semester. Because for a subject, there are 3 group discussion, 2 in a semester and 1 in an examination. And he will also listen to the group discussion by the other. Apart from that, VIT, when the NAAC committee visited, the honorable members were there. Dr. Durga Singh Chauhan was there that day. So he appreciated that the student curricular activities, extracurricular activities and co-curricular activities are abundant in VIT, where the students themselves participate, they themselves organize, and there are more than 50 clubs where the student will organize. So I will just quote an example how the decision making of the student. See, of course, when we do any scheme, the beneficiaries are there, but the degree of benefit is different for all. Now, when the COVID pandemic came, our 21st March was one event scheduled, and we have already spent 1.5 lakhs for that. TEDx. TED Talk was there on 21st of March, and 1.5 lakhs rupees were spent, and 600 plus delegates, student delegates from all over the state were invited for that. And lockdown was announced on 14th of March in Pune. Now the students started questioning whether that TEDx should happen or not. What should happen that time? And then what I did, they called me also. They called the respective dean, they called the dean finance, the dean administration, and they called me also. I told them, see, I can give the decision, yes or no, but you have to own the decision. This is the practical thing that has happened. You deliberate amongst yourself for 2 days and you tell me on 17th of March what should be done on 21st of March. And they came up with the solution. They said, sir, we don't want to take this TEDx. Let 1.5 gaya to hamara chalega, lekun humko nahi karna. And we said that college will bear that cost.
Good, sir. So much of stuff is there with you. Means you have quantity of work what you have done as per the performance. It's very clearly indicating. So because it's already we have already finished the time. So moving ahead with the vote of thanks concept, I really appreciate Dr. Rajesh ji, your team, Dr. Vijay Gaikwad, who was really striving hard to make it possible, and Dr. Ganesh Dongre ji, Ashutosh Marathe ji, and Rahul Paikar ji for coming out with a really an excellent performance. So, Dr. Kamble, I request you to please proceed with the formal vote of thanks. Dr. Kamble, please.
Yeah, sir. Thank you very much, sir. Good morning to all participants and their colleagues. On this, it gives me immense pleasure to propose vote of thanks for this today's webinar on best practices adopted by accredited NAAC accredited institute, Vishwakarma Institute of Technology, Pune. First of all, I am very much thankful to our beloved Honorable Director, Professor S.C. Sharma sir, for his valuable support, encouragement, and providing these opportunities for organizing this today's webinar. So once again, I sincerely thank to our Honorable Director sir. On behalf of the NAAC family, I am extremely thankful to Professors Rajesh Jalnekar, Director VIT Pune, and his panelist team, Professor Vijay Gaikwad, Dean IQAC, Professor Ganesh Dongre, Dean, Professor Ashutosh Marathe, Dean, Professor Rahul Paikar, and Vijay Mane, Dean of VIT Pune. All those panelists have given a wonderful presentation with several examples on best practices, interactive and experiential learning approach for cultivating innovation among our students. On behalf of NAAC, I am very much thankful to all the participants, those who have joined from different parts of the country. I thank all the advisors, consultants, ICT units, and supporting staff of NAAC for their support and motivation to conduct this today's webinar, make it successfully. Thank you, one and all. Thank you, sir.
So many thanks, Kamleji. Would you like to speak something, Rajesh ji? Would you like to speak something?
Sir, I am really thankful to you, especially Dr. Devendraji, I am very thankful to you for your very enlightening questions and really encouraged us and gave us the confidence that we should go ahead with what we are doing. Without your appreciation and insightful questions, we would not have been motivated to continue our good work. I say good work because you appreciated it as good work. So I'm very happy to present to you all and very grateful to all of you for giving us this opportunity to present our case study. I'm also thankful to our team, Dr. Dongre, Dr. Vijay Gaikwad, Dr. Marathe, Dr. Vijay Mane, and Dr. Rahul Vaikar for contributing to this presentation and discussions. And a special thank to Lina Madam and Kamble sir also, who has been following with me now from more than 3 weeks now. And thank you to Sharma sir also for giving us this opportunity. And thank you to you, sir, especially for encouraging us. Thank you so much.
Yes, so many thanks. Yes, so many thanks to all. You have a very good team. So many thanks to participants to participate patiently and learn many things and ask the questions. Thanks to Dr. Lina Ghan, especially coming out for the crisis, and she helped me in asking me the questions. One very important thing and appeal to all the participants, we are continuing the series of best practices adopted by AWS in this series. On 14th, we have Indian Institute of Science. They are coming for the presentation, and then on 20 and 29, two more prestigious institutions which are coming. The link is already there available in our website. You can participate and register to learn so many good things, just like what you have learned from this very good institution. Really appreciable, Dr. Rajesh and your team. सही में बहुत अच्छा, it's commendable, and I think so.
Thank you, sir.
Of course, it's dil se, it's a perfect thing. I hope all the students in your area and the students of the country will be benefited. Stakeholders who has participated in this webinar will be beneficial by your deliberation. So many thanks. Thanks to everybody. Thank you. Namaste.
Thank you, sir. Thank you.
Yes. Samuel, you may close the session.